All right, this video is going to look a little bit different than my other videos because I am needing to use a protractor and a ruler to draw out our geometric vectors. And so maybe it's been a little bit since you used a protractor. So here we go. Here's my little broken ruler and my protractor. Let's see how this goes. Now, I am doing 3 problems. They're straight off your homework assignment. So hopefully you have your homework assignment and have the full question written out. But for this one, I'm going to do number 9 to start with. I kind of like it because it kind of is a common sense type of situation. So what's going on here is Joe kicks a soccer ball at 15 with 15 newtons of force, and he's kicking it straight at 90 degrees. So think unit circle here as we're doing this. And at the exact same time, Jerry is going to kick the ball with 20 newtons of force towards 0. So in other words, what's happening here is that, let me grab a pencil because I'm probably going to goof up. I better use a pencil. All right, so it's like you have this ball right here, and one of them's kicking it this way and the other one's kicking it this way at the same time. If they kick it at the same time, then it's probably going to shoot off somewhere at an angle. And angle, that would be what we would consider our resulting vector, and that's what we are in search of. Now, to draw geometric vectors, we actually won't draw them like that, what I just did there. What we're going to be doing is using a method called tip to tail. As you start with one vector, and where that one ends, the next one picks up and starts. And then the next one starts where that one ends. And then your resultant is what happened from beginning to end. All right, so let's start with this one. Joe is going to kick the ball. Now, if I'm going to do tip to tail, it would be kind of smart to plan ahead because invariably you end up running off your paper. So I know that I'm going to go 90 degrees with 15 newtons of force. So it's going to go this way, but then I'm going to have to go 0 degrees with 20 newtons force, so it's going to go this way a little bit longer. Okay, so then with that idea, my resultant is going to be this right here, start to finish, what happened. I'm going to go up and I'm going to go over, so I'm going to start way down here. I like to use like a little dot as my starting point. And now I'm going to grab my protractor and I'm going to mark the vector that Joe is kicking the ball at, which is at 90 degrees. You will always hold your protractor horizontally. It's always going to look like this. You're never going to like turn it at an angle or anything like that. You might need to flip it upside down, and that will be okay, but as long as you're keeping it horizontal. Now, I want to start this way, and I'm going to put the hole of that protractor, my protractor has a hole in it, and keep it very, very straight as best you can, and you're going to mark 90 degrees up here. Now what we're finding there is the direction of the vector. Next, we're going to find the magnitude of that vector. Now, if you had your homework assignment and you were looking at it and read this full problem, then you would know that they gave you a scale to work with, and 1 centimeter is equal to, what was it now? I'm forgetting. Was that 2 newtons? 1 centimeter was 2 newtons, I think. Or maybe it said a 1/2 centimeter is 1 newton. I forget how it was marked. But regardless, if I have 15 newtons of force, well, that's going to end up being 7.5 centimeters. So this 15 Newton, I'm really going to use a 7.5 centimeter when I draw this out. 20 newtons is going to end up being 10 centimeters when I draw that out. So then I'm going to grab my ruler, and this vector that's going at 90 degrees, line it up here, and it needs to be 7.5 centimeters. I feel like I'm going to just be, yeah, like look at my hand. It's right over top of what I'm doing here. Hopefully you can figure out what I'm doing. I'm just drawing that out, going to 7.5. And then I'm going to put an arrow to show the direction that I went. Okay, now bear with me. This is going to be just as awkward for me to draw it here as it would be if I was doing it on the board. I can already tell I'm off a little bit, so my answers probably are not going to be ideal, but I wanted to show you how we draw these out. Now, tip to tail. This is vector Joe. We usually will label them because they're going to start getting messy. We want to keep track of what we've done. Your vector needs to have two characteristics. It's got to have an exact magnitude, so precision is going to be important. And you have to have the arrow showing which direction it went. So I put my arrow here, but it's a nice clean arrow. It doesn't extend the magnitude at all. Now, where that one ends, my next one picks up. So I'm going to grab my protractor, and I'm going to put it at the end of that arrow. And again, holding it very, very horizontally. Now you're going to mark 0 degrees, because now I'm going to do the second vector here that goes towards 0 degrees. And then I'm going to grab my ruler, and I'm going to draw it 10 centimeters towards that. Now, since it's going towards 0, I put an arrow to show that direction. Boy, I really was hoping to be neater than this. I'm going to get better. Be better. Okay, here we go. Your resultant vector, well, hang on a second. That was vector Jerry, right? So let's go ahead and label that. Vector Jerry. Notice the notation. It's like a line with a little half arrow going. That's how you notate vectors. Now, what's really going to happen is the ball is going to go somewhere between where Joe kicked it and Jerry kicked it. And this right here is my resultant. And I would like to designate that a little bit differently. So I usually like to dash the resultant. I can use a red pen or a highlighter, but if I goof up, there's no going back with those. So I'm going to just dash my resulting vector here. And then I'm going to label it with a capital R for resultant. Now, from beginning to end, the ball went this direction. So my resultant vector should have an arrow at that tip. Now, that's kind of a confusing thing for some people. We kind of regress back to the first grade when we're doing dot to dot, and we go here, and then we go to there to kind of close it in. But the arrow should not be going that way, because from beginning to end, the ball is actually going this direction. Okay, so now our goal is to answer or to describe that resultant in the same way it was given to me, like this right here. So first thing I'm going to do is going to measure it. Okay, I'm going to go with a 12.5 centimeters. Now think about this though. If it is 12.5 centimeters, I really want to convert that to newtons. So really what I would write is that it's 25 newtons of force. So with both of them kicking the ball, it actually got hit harder than either one of them individually did. Joe kicked it with 15 newtons, Jerry with 20 newtons. My end result was a 25 newton. The next thing I'm going to do is measure the angle. Now, always think about what quadrant your resulting vector is going towards. This is going towards the first quadrant. So I would want an angle that would land in the first quadrant. So I come over here, I grab my protractor, and I'm going to line it up. Again, horizontally at my starting spot. And then I'm just looking up here to see what angle it looks like that is hitting at. And so it looks to me like it hit right here at, now the question is, do I want to say that it's 145 because it's between the 140 and 150? Or would I want to call it a 35 because it falls in there? Well, that's what I say. Like, which number am I supposed to be using? Well, you got to use your common sense. It's going towards the first quadrant. I want that to be a 35, not 145. 35 degrees. So the way that I would write this then is I'd say my resultant is 25 newtons at 35 degrees. Now, I don't know if that's exactly right. I'm just sketching it, and I've already forewarned you that my sketches are not going to be great because I'm trying to do this with a camera, and I hope that you can see what we're doing. Okay, so that was our first one. I hope that sort of makes sense. Even though I'm not drawing it like I did up here, where they're hitting it at the same time, I'm doing this tip to tail business, and it still gets me to my resultant appropriately. All right, I'm done with number 9. Let's move on. Now, I'm doing 3 of these with you, so that's like bonus. If you'll do these with me, then you'll have 3 problems on your homework already done. We're going to jump to number 5. It doesn't really matter if you do these in order on your paper or not. I'm just going to be looking for the different drawings. Now, this vector, looks like we want to take vector C. So on your homework sheet, this is your vector C right here. It's 3 centimeters at 120 degrees. I'm going to plan this out. So 120 degrees is like right here, and it would be 3 centimeters. And then it's a minus 3 times vector E. All right, a couple things going on here. 3 times vector E is going to affect the magnitude of the vector. So vector E is 2.5 centimeters, but ultimately I'm doing 3 of them. So that would end up being 7.5 centimeters. So that's going to be quite a bit longer than what my C vector was. Okay, the other thing that's different is that I am subtracting. Subtraction works differently. What you do on subtraction is you go the exact opposite direction that you feel like you should be going. So vector E is marked to be 155 degrees. Well, the 155 would be like somewhere here, this way. But what I do is instead of going that way, I go the exact opposite way. It's sort of like that negative R value when we did polars. So it's really going to go down this way, 7.5. All right, and then my resultant is going to be from start to finish. It's going to go this way here. So by looking at that and kind of planning this out, I can see that my resultant is going to be going probably towards the 4th quadrant. So my angle is going to be like in the 300s probably. And it also kind of helps me decide where I want to start. I feel like I'm going to start right here, and that's going to give me some, keep scooching over a little bit more, maybe right here. And that should give me room to go up and come back down. Okay, so first thing, grab your protractor, hold it horizontally, and mark your first angle. Your first angle here is the vector, did I say angle? I meant vector C, which has an angle of 120 degrees. So here's my 120. I'm going to mark it. And then I'm going to grab my ruler, and I'm going to make a vector. That is, vector C is supposed to be 3 centimeters. Oh my gosh, I just realized you can't see this. That's kind of bad. Okay, sorry. This is what I'm looking at right here. All right, do you have that? If you had your homework out, you'd see where I was getting that. But I do have it here for my benefit as much as for yours, because you have yours in front of you. So I am doing my vector E and my vector C here, these 2 vectors. These were the given vectors on your homework. Okay, so now I'm going to come back over here where you can see what I'm drawing. Right here. Okie doke. I've got my direction at 120. Now I'm going to make this be 3 centimeters long. So line it up. I'm putting it at a 7, and I'm just going to draw till I get to 4. There's my 3 centimeters. Now I'm going to put an arrow right here. Don't go clear to that point. Don't like dash or anything. There's a distinct magnitude, and it can only be this long. Make it stop. This is vector C. Now what I'm going to do is I'm going to do negative or minus 3e. So it feels like I should be holding my protractor here and then going over and marking the 155. But since it's a minus, I'm going to take my protractor and I'm going to flip it upside down. And instead of going off to the left there, I'm going to kind of come down and find the 155 that's down here. So there's 150, 160, so 155 would be about right there. And then I'm going to grab my ruler and I'm going to make this vector. And I kind of like to show that it was 3 vectors long. So what I'm going to do is I'm going to go ahead and I'm going to start at 0. And I know that it's 2.5. So I'm going to go, well, but it's 3 times that. So I know it's going to be 7.5. So it's going to end right there. And then I'm going to go ahead and mark my 2.5. Mark the 5, because here's what I kind of like to do. I like to show that this is 3 vector lengths right here. Now this dot is from me marking my protractor, so that doesn't really mean anything. This is the designated end point or the terminal point of my vector. This is -3e. All right, so now we're ready for our resultant. Our resultant is going to start where we started and it's going to end where we ended. So this right here is going to be the resultant, and in the end, from beginning, remember we're dashing, to end, I'm going kind of towards the 4th quadrant. Let's see if we can figure out our magnitude and direction. Okay, magnitude, I'm just going to, I got my ruler here, I'm going to go ahead and measure it. All right, I've got a I'd probably say like a 5.4 is what I would say there. So this vector, my resultant, is going to be 5.4 centimeters at, now let's see if we can figure out the angle. I cannot hold my protractor like this. Remember, when you're measuring your resultant, you go back to the beginning. I am going to have to flip my protractor upside down. But there is no way any number on my protractor is going to give me a 300 number like I think it's supposed to be. So this is where you got to use your unit circle knowledge, just your overall common sense knowledge, I guess. Because if I note where that went, I'm in trouble on this. Because, all right, so I'm going to do something here that I told you don't do. I'm going to have to extend this, but I'm going to come back and erase it later. So this is going to clear out there. Okay. So if I come here and line this back up and hold it horizontally, that line, why do I have to write my answer right here? Okay, that looks like about a 8 maybe, or a 9. Okay, I think it looks like a 9, but I'm pretty sure it's supposed to be like a 6. So maybe yours is better. But so let's say it's this 9 degrees. Well, obviously my answer is not 9. It's just 9 down from the horizontal. So it would look something like this. And this angle here is 9 degrees. If that angle is 9 degrees, really what I've got going is I've got the angle that's going all the way around, but I've got a 9-degree gap here, so I didn't make it to 360. What I really made it to was 351. So then I would say at 351 degrees. Again, I know that that is not exactly accurate, but I'm doing my best here with what I've got. Make sure you come back and erase that extension because I don't want you to think that the magnitude is any longer than what it is. Okay, I have one more. All right, I have the same vectors you can see right here, but I'm going to be using different vectors for this problem. I'm going to be using C, I'm going to be using E, I'm going to be using A. This is problem number 11 on your homework. All right, let me bring this up so I have a little bit more room to work. And I'm going to do vector C first. Vector C was 3 centimeters, so I'm going to plan ahead here. I'm going to do it where you can see it this time. I'm not sure if you could see it last time. So I'm going to go at 120 degrees for 3 centimeters. And then it's a plus 2E. E happens to go at 155, so that's going to shoot off this direction. But it's 2E, so it's going to end up being like 5 centimeters, so it's a little bit longer. And now I've got subtraction. And A, vector A is straight up to 90, but since I'm subtracting, I'm going to go straight down. Go the exact opposite direction. And it's twice as long. Oh gosh, that's going to make it like 9. Okie doke. So obviously I'm going to have to leave myself some room to go both up, but also quite a bit to go down. So I'm going to get that a little bit out of my way here. Good thing I switched to that pencil. Okie doke. Let's see how I can do this. I'm going to start over here and put a dot. And then I'm going to go ahead and hold my protractor horizontally, and I'm going to mark 120 degrees. 120 is right here. And I should just do this on a piece of scratch paper. What if I did that? I'm going to do that. Looky here. I got a blank piece of paper. Boom. Now I'm not going to run into everything. And I have lots of room to work. So I'm going to start over. Sorry. Here's my dot. Okay. I'm going to mark. This is going to be my vector C. I'm going to mark 120 degrees. And I am going to go got all kinds of papers and stuff. I'm standing over my desk here. This looks ridiculous. Okay, 3 centimeters. Got it. Okay. So line this up. I'm going to put it at the 10 mark and draw it to the 7. Nice clean line, nice clean arrow. Vector C. Okay, so that right there, there's 3 things I'm looking for. Is it the right length? Do you have the arrow on it? And have you labeled it? Those 3 things every time. Next, I'm looking back at what I had. It said plus 2e. So vector E goes at 155 degrees. So again, I'm going to hold my protractor here. Where that one ended, my next one starts. So I'm going to do that. Mark 155 over here. Can you see that? Oop, it's a little bit off. 155 is right here. And then this is 2e. So it's going to, in the end, be 5 centimeters long. But again, I kind of like to show that it was an extension. It was a 2.5 magnitude vector that got multiplied by 2. So I'm going to call that plus 2e. Labeled the right length and have arrows to show direction. Now it's a minus 2a. Vector A was 90 degrees. So normally then I would hold it up here and I'd mark my 90, but I'm going to flip it upside down because of the minus sign. And so I'm really going to go 90 downward instead. So I'm going to mark my 90. Then I'm going to grab my ruler and let's see what it said. It said 2a and a is 4.5. So this is going to end up being 9. Ooh, my light just went off. Uh-oh. But I'm going to mark the 4.5 so I can make it look like 2 vectors. Boom, boom. All right. Not sure why my light went off. Okay, there we go. All right, and then I'm going to label this. Okay. -2 vector A. So now the resultant is what I did from beginning to end. So my first point was here. My terminal point is down here. So I'm going to go ahead and draw that and dash it because it's going to be my resultant. Notice the direction I'm dashing it. That's just out of habit because I know that's the direction of my vector. It started here and it went down here. It's going towards the 3rd quadrant. So when I write the resultant measurements, I got to keep that in mind. This should be an angle that's going towards the third quadrant. All right, I've got the length correct. I've got the arrow. Just be sure to label that as your resultant. We use a capital R for resultant. Now, the moment of truth. How'd we do? I don't love this. I hope that yours is a little neater than that. I'm going to go with a 7.3. I think that's what I want to say. So I would say that the resultant is equal to 7.3 centimeters at, now let's find the angle. The angle, I can't measure it with my protractor upright. I'm going to have to spin my protractor this way. And then the question becomes, which number do I use down there? Well, really, it's neither. Neither one of them is going to be the answer. You got to think about what's going on. It looks like it's about at a, what I might say 143 is what that looks like. Or you could call it a 37. All right, so I'm going to use the 37 because in my mind, here's what's going on. That 37 is right here. Oops, you can't see that. That 37 is right here. So the angle is actually going to be a 180 plus that 37 that I had. So 180 plus 37 is a 117 degrees. All right, that is my resultant. Okay, so that's 3 of them. Now, and I don't really feel like I did awesome on my drawings. I'm not sure if my angles are totally correct. You do yours, and if you're off a little bit, that's going to be okay. I do give you some leeway. You should be, and I'm not saying from this answer, but I'm saying from my answer key when I grade it, I give you 2/10 here, and I give you 2 degrees leeway. So you have a little bit of wiggle room, but not a ton. So be really neat. Make sure you're showing direction and magnitude on each vector that you draw and that your resultant is dashed. Just like this. No shortcuts. All right, go do the other ones. It's kind of fun. It's something different.